So this video is on vectors. And before I get into vectors, let's just recap arrays. All right, so when we make an array, um, we have to know how many index variables we want in that array before, while we're writing the program. So we would have to do something like this: int array, and then give it a size. And then that will have the compiler allocate enough memory space to hold 10 integers. And so some of the problems with an array is, what if we don't know how many index variables we need for our program? What if our program is a little more dynamic and we don't know from the beginning when we're writing the program that we're going to need 10 index arrays. So one thing that we did with arrays is that we did partial arrays. And with partial arrays, we pretty much allocated a really large space. We would have to think, okay, I'm probably not going to need more than 100 index variables, so let me just create space for 100, and therefore I will make sure that I do not go over the space that I need. At least I will make sure that I have enough space for all the variables that I think I'll need in the program. Well, the problem with that is that we end up with memory that we're not used. We'll reserve memory for a program, and then we probably won't use it. Say we made an array for 100, and then we figure out that we only need 15 index variables, then we're left with 85 times 4 bytes of memory that's just wasted. So that's one of the downfalls of an array. And unfortunately, we can't resize our array. We can't we can't later on in our program say, if we need 200 now, we can't say array 200 because that is actually not resizing an array. That is actually just giving us the index of 200. And so this is something that we are not allowed to do. So that can be a problem. Another problem with arrays is when we're using it in a function. First of all, we can't return an array as a function, right? If I was to try to say, here's my function, and I want my function to return an array, it would be nice if we can do that, but unfortunately in C++ we can't do that as well. Another issue with arrays is if we wanted to use an array as a parameter inside our function, then we also have to pass in the size, unless we use the size as a global variable. But using the size as a global variable limits us if we need to use our functions in other programs. Right, so this is what we usually have to do when we create an array. So we would have to keep track of what the size is of the array. And when we're using partial arrays, not only do we have to keep track of what the size of the array is, but then we also have to keep track of the actual index variables that we use in an array. What I mean by that is if I have an array for 100 index variables, then as I keep adding stuff to my variable, say I say index 0 equals 500, then I need to have another variable called, usually we call it num used. And then every time I add something to my array, then I have to increment num used. And so that actually, it gives us more things that we have to control. It gives us more room for errors. What if we don't increment this at the right time? Or what if we increment it and we actually didn't add something to our array? Then we can start losing track of our array, and we can get out of sync. So a way to fix that is a class called a vector, right? And a vector is pretty much a class that has a dynamic array as a member variable, and that dynamic array will resize itself as you need to put more elements inside the array, more index variables inside the array. And so one good thing about classes, and we learned this in chapter 6, is that we don't really need to care about how the class works as long as it's getting the job done. So me getting into how an array works is not really important. How a vector works is really not important. But basically, this is how it works. So say we have an array, right? And let's say we start off with an array with 10. As we start adding new things in our array, so if we say, array 0 equals 1, and then we go to array 9, and let's say we make that equal 10. As we start adding things into our array, once we get to index 9, of course, our array of size 10 is full. So what a vector will do is it will create a new array, right? So it'll say new array. And usually what it does is it will just double the size of that array. So since if the array started at 10, then it'll create a new array of size 20. And then what it'll do is it will copy everything. So let's say this is our array here. This is our first array. And let's just say this is 10 elements. All right, so we have 0, 1, 2, 3, and then this is 9. So let's say we have all of these in our array. Then it will create a new array of size 20. So let's just say this is our array. I'm just going to do ... All right, and so then it will start copying what's in this array. So it's going to bring this here, and it's going to bring all the elements into this new array. All right, and now this array is a partially filled array, and it has all the elements that were put into the old array, copies it to the new array, so now the array has more room to add more elements to it. And so that's the way that's the way a vector works. Of course, we still have the issue with memory, right? We still have issue because if the array is doubling each time, then we still will have space that's wasted, but we won't have as much space as wasted because, in the prior example, if I had an array of size 100 and then I only used 15, then I wasted 85 memory addresses. But if I have a vector where it just doubles in size, if I decide that I need 15, it doubles in size to 20. It starts off at 10, it doubles in size to 20, then we use 15, then that means that we're only left with 5 wasted memory addresses. And so that's a lot better than 85 or whatever number we would choose to set our array if we did not use a vector. So the way we add stuff to a vector, so we can use a vector very similar to the way we use an array. So to declare a vector, it's a little new syntax that we haven't learned yet. We basically need to include vector inside of our program. So we'll say include vector. And now this allows us to use our vector in our program. And of course, if you want to use namespace, we can say using namespace std. All right, and so now we can use a vector inside of our program. So say we're inside our int main, and inside our int main, to declare a vector, we're going to use the vector data type. And this is the new syntax. Of course, if we want to have a vector of integers, then we have to let the class know that we want this vector to store integers inside of its dynamic arrays. And so the way we do that is we use the less than and greater than, and we'll just put in our data type. Right, so now this is our actual data type. This whole thing here is our data type. And that basically is saying that we are creating a vector of type integer. And then of course we name our vector. And for here, I'm just gonna call it V. Right, this is our identifier. And of course we need a semicolon. So now I have a vector of and when we declare the vector has nothing in it, right? So we don't need to give it a size. We don't need to say how many index variables we need for our vector, because a vector doesn't care about that. A vector is going to just keep taking in integers as long as we need them. So all I need to do is just start adding things to my vector, and it will store those variables inside my vector. All right, and so a way to do that is, if we're gonna, for our first index variable, add it to our vector. We must use a member function called pushback. And basically what pushback is a function. It's a member function in the class that has one argument. All right, so our pushback will be something like this. And we don't have to write this function because this actually is a member function of our class, but it will look something like this. Pushback, and then it will take an integer item. And if we pass an integer into this function, then it will add that vector to the end of our array, right? And so to use this function, what do we need? To use this function, we are going to need to use the dot operator. And you should remember the dot operator from chapter 6. We used it a lot for a lot of our IOStream objects. So vector is, when we declare our vector here, right, we just created a object of type vector. Type vector int. Right, so if I have a vector called v, then I say v dot push back, and then I'll put in my argument, which, let's say I want to put in the number 15. Now I have a vector that has one item in it, and that item is the number 15. If I want to add more, I can just say push back, and let's say I push back the number 27. Now my vector has two items inside of it, right? So this is be the same as having a array of size 2, where I have the numbers 15 and 17 inside, 15 and 27 inside my array, right? And just like a array, if I wanted to get the value, say I wanted to see out the first element inside of my array. This is also zero index, so I would say see out v 0, right? And if I did that, this would print the number 15. If I said see out v1, then this will print out the number 27. Similar to an array, if I wanted to change the value at a particular index, I can do that by simply saying v1 is equal to 30. And now the index variable changed from the number 27 to the number 30. There's also a member function that we can use. So this is one way to output, right? We could also reference our index variable in another way. We can use a function called at. And since it's a function, we use parentheses and we say v at, and then we pass in our index. So if I wanted to say v at 0, right, this is going to be the number 15, right, since 15 is stored at 0. So those are the two ways that we can access it. And we can actually do a really weird syntax. I could say v dot at 0 is equal to 31. And now the index at 0 will change to the number 31. There's lots of other functions that come along with the vector. I'm just going to go over a few. We have one that is a Boolean, and it's called empty. And this will return true if there are no index variables inside of our vector. All right, for instance, I could, if I had a if statement, I could say if v dot empty, all right, and this would return true or false. And if it is empty, then I can say, let's say something like see out no items. All right. Another really cool thing about vectors is a function called size. And that size returns an integer. And what size does is it actually returns the number of index variables that have been added to the vector. All right, so let's just give an example of that. So right here I have my if statement that says if the vector is empty, then we're going to see out there are no items in the vector. But now I can do something like this and say if it's empty, there are no items in the vector, else then we can see out there are v dot size right? And then that would tell me how many items are in the vector. There's also another function, front, and this will pretty much return the first element inside the vector. This will let you know what the first element in the vector is. So those are some of the main functions that we would need. Definitely read up on more functions available for the vector. But if you wanted to use your vector like you use a array, those functions right there would be enough. So just one thing to keep in mind. Remember I said if you are adding the first element, you must use the pushback function. After you use the pushback function, then you could do something like this, where you can just call an index and you can add index variable to your vector the way we do an array. All right, so another plus side for a vector is, remember I said earlier, I cannot have a vector as I cannot have an array as a return type for a function. That is not the case for a vector. I could create a function that will return a vector, right? So this will return an object that holds multiple index variables. So that's actually pretty exciting, right? So I can just say my function, and in my function, I could do some sort of algorithm. Say I want to create a vector, call it v, and then I want to do like a for loop. And then I could say v dot pushback I, and then after that function is done, I can say return v. And now I have a function that can return 10 index variables in one object. So that's pretty cool. Also, if I wanted to have a function that takes a vector as an object, I can do that as well. All right, and notice I don't have to put the size in there because because my vector knows the size. So I could say something like for int I equals 0, while I is less than v dot size I plus plus. And then I can say something like cout v I all right, and then we'll just say cout and all right, and so now I can have a vector as an argument, and I don't have to worry about the size because the vector itself knows the size. It knows how many elements are in that array. All right, and so those are the basics of a function, of a vector. They definitely make our lives a lot more easy, just because we don't have to know how many variables we need in our array. And we can actually write functions that can return object of index variables. So a vector is a very cool data structure. It definitely fixes some of the problems with arrays. Of course, the downfall of a vector is that it can take up more memory because every time you reach the capacity of your vector, then the vector will double. So if you had a program that needed 101 index variables, and once you got to 100, the vector doubled to 200, then now you have 99 index variables that you don't need. So there are some downfalls for using vectors, and but it actually is less frustrating than using arrays in some cases. All right, and our secret word is remote. And thank you for watching. Have a great one.